The HeteroFoaM Center is a collaboration of 7 universities and 3 national labs. The purpose of that center is to learn how to design heterogeneous functional materials, or heterofoam. These are material systems that actually play an essential role in our society. We use them to convert energy, for example, to store in batteries and to use in fuel cells to make electricity. We also use them to make solid-state membranes, which are used by the processing industry for making chemicals. And as a matter of fact, they're used in jet engines for coatings to resist the heat in the structures. These complex material systems presently are being made one at a time by an incremental process which costs a lot of money and takes a lot of time. They're not being designed with models and understanding, so we would like to change that. The purpose of the center is to design heterogeneous functional materials from our knowledge base.
We've been using several facilities in collaboration with the National Synchrotron Light Source, the new National Synchrotron Light Source 2, as well as the Center for Functional Nanomaterials. We have been using these facilities to obtain detailed three-dimensional images of the material structure, to obtain details in 3 dimensions about the chemical bonding and the elemental specificity of these materials, thereby enabling us to better understand how these materials work and how to design them better.
Our BIM9 enables the HeteroFoaM Center to study microstructure of energy materials in 3D at a nanometer resolution and to identify the chemical composition of the materials.
We're standing right here now in one of the newest synchrotron sources in the United States, probably in the world, the National Synchrotron Light Source 2. And this facility allows us to better understand fundamentally how heterofoams work.
The National Synchrotron Light Source 2 is the most advanced synchrotron facility in the world, sponsored by Department of Energy. Now it's under construction. We will have a first X-rays in late summer this year. And the most unique feature of the facility is that this is the brightest synchrotron source in the world, meaning that X-rays produced here have the smallest source size and source angle. We can use these features to probe the interfaces of a number of important materials that are produced at the center.
The research that this team does starts at the atomic level and goes all the way to the device level. So our researchers are charged with the responsibility or with the task of understanding how to put atoms together, then how to put grains and parts and little pieces, nanoparticles together, then how those can be combined into a system using different kinds of particles, and finally, how does that perform this functional behavior? How does it operate on a field? How does it operate on energy or electricity? And how does that produce a systems response?
The HeteroFoaM Center is an extremely exciting environment to work in. I think one of the main points of the center are the collaborative opportunities with other leading scientists in the area. For example, I'm able to work with material scientists that give me a very good idea about the material sets and requirements that are needed for a specific technology. I'm able to work with experimentalists that are able to provide me with data so I can accurately validate my numerical models. But most important of all, because these are all considered leaders in their field, I can go to them and discuss my latest research, share opinions, and be able to formulate next steps towards our scientific contributions.
The key thing is what we try to do with our computations is more than just essentially confirming experiments. We really try to understand mechanisms which are very difficult to experimentally determine. And even more important, we try to rationally design materials so that we essentially can move beyond make and observe methods.
Right now we have a situation where we have a limited capability to deal with new fuels and new capabilities for energy conversion and storage. Our center has the great hope to change that, and by bringing together this group supported by the Department of Energy for an Energy Frontier Research Center, we are able to actually achieve an advance in infrastructure flexibility.